Hi, welcome to day 5. Today we're going to discuss object oriented programming, encapsulation, inheritance, polymorphism, and then demo of all of the above things. Before going into object oriented programming, let's discuss why we need object oriented programming. So the object-oriented programming mainly used when we want to reuse our code, right? So we don't need to rewrite the code. We can use existing code and we can extend that code with our new functionality. Right? Let's see how we can do this in object-oriented programming, and then what are the advantages of encapsulation, inheritance, and polymorphism. So let's get started. So an object-based application in Java is based on declaring classes, creating objects from them, and interacting between these objects. So mainly in object-oriented programming, we have objects, and the objects behaves like a real-world objects, and they communicate with each other. They pass the messages to each other, and they inherit the properties from their parent classes. So let's say a real-time example. Let's say you have a vehicle class, so vehicle class have some defined methods, right? And you are going to create some car classes, for example, BMW, Toyota, or any other car class, which need to inherit some of the methods, but then it's going to extend the functionality, or maybe in other words, we say going to override that functionality and provide the new features. So it can have some existing features, plus it can add up the new features. So this is the main purpose of object-oriented programming. The building blocks of object-oriented programming are following: inheritance, encapsulation, abstraction, and polymorphism. We'll see step by step what these are and how we achieve object-oriented programming by using these concepts. So the benefits of object-oriented programming are following: improved productivity during software development. So, because if you already have functions available, you don't need to rewrite that code. It means improve your productivity, and you can release your software earlier in a market than rewriting the code, retesting the code. So it gives you flexibility that you can reuse your existing code or reuse the existing libraries. You can improve software maintainability, because it will be easily maintainable. If it's, let's say, you have one class which is inheriting all the methods, at one place you need to go and make changes, and other classes will automatically have those changes. So that's easily maintainable software. Faster development sprints, lower cost of development because you need to write less code. You need to spend less time on QA, so that's why it's lower cost on development, and it's higher quality software. So what is inheritance? Inheritance in one such concept where the properties of one class can be inherited by the other. It helps to reuse the code and establish the relationship between different classes. So the main focus is on reuse the code. So let's assume the parent class. Parent class is always called a super or a base class, and the class which extend that class or which inherit from it is called a child class or a subclass or a derived class. So you see all three different words in different books. So child class, subclass, or derived class, they are the same things. They are extending some class which is become their parent class or a super class or a base class, right? So a class which inherits the properties is known as a child class, whereas a class whose properties are inherited is known as a parent class. So let's take an example. There is a class A here. So this class A, which has some properties and some methods, right? And there is another class B which need those properties and methods, and they belongs to some kind of a same family. So they want to extend that class. For example, you have an animal class. An animal can have a very similar features. So when we need to define a tiger class, we can say my tiger class will be a child class and animal class will be a parent class. So we can inherit all the properties and the methods. For example, the animals have legs, The animals have height, they have colors, they can eat, they can smell. So these kind of features, these are their properties, their behaviors, which we can inherit from class A. So we don't need to write those things again in class B. Again, all the animals walk, they eat, they sleep. So they have different kind of patterns, right, like that. So these are the methods which you already defined in class A, and then you can reuse them in a class B. So this is the benefit of having the inheritance, that if something is already defined in one class, you can define your own class, which is the child class of the parent class. So the syntax is the class B, which is the class B, it can be any class, and the keyword is extends. So it extends a class A. Class A can be any parent class, and then inside that class you can define your own properties and you can define your own methods, but you already have the properties and methods defined in a class A. What is encapsulation? Encapsulation is a mechanism where we bind the data and code together as a single unit. It also means to hide the data in order to make it safe from any modification. In encapsulation, the methods and variables of a class are well hidden and safe. So declaring the variable of a class as a private, providing public setters and getter methods to modify the variable's value. So the encapsulation is actually where you hide your properties. So the properties cannot be changed or modified or even accessible by any other class externally. So what if they need to access that properties, right? How we give them an access will be given through the setters and the getters method. So for example, you have a property called age, right, int age, and you don't want a object to change a property directly, right? You want, if someone use your class, they must create an object, and then from that object they use a method called get age and set age. So these two methods will be public, but the property itself will be private. So by mistake, no code will be able to change it unless they will call it setter method. Abstraction. It basically deals with hiding the details and showing the essential things to the user. Real life example is a TV remote control. We hide all the complexities inside the remote control and provide a user-friendly interface to the user to control volumes and channels. So you don't know how the TV operates. You are not going to check any circuits inside it, like how I'm going to reduce the volume, switch on or switch off. You don't need to write any commands or anything. You have been given a remote control and then you just press the buttons. Button plus means increase the volume, minus means decrease the volume, and that's all you need to know, right? This is called abstraction. So all the complexity of the mechanism involved in operating a television has been abstracted out, they have been hidden from you, and you have been given a very easy way to control your television. We can achieve abstraction in two ways. So one is abstract class, another is interface. We will see what abstract class is and what is an interface. So abstract class in Java contains the abstract keyword. If a class is declared abstract, it cannot be instantiated, which means you cannot create an object of an abstract class. Also, an abstract class can contain abstract as well as concrete methods. So abstract method means they will not have any body, they will not have any steps to execute, and only classes which inherit that abstract class, they must provide the body for that methods. But they also have a concrete method, and concrete method means they will have an implementations of the method. So any class which going to extend that abstract class will automatically get that body or that implementation. Abstract methods have no body, as I mentioned. The classes which extends the abstract class will provide a body for abstract methods. So, how abstract class looks like? So we define abstract class vehicle. So we need to define abstract keyword, then a class and the name of that class, and then inside we specify the properties and any concrete method. So the run is a concrete method, but this increase speed is an abstract method. So the class BMW, which extend the vehicle class, it provides its own property like engine type, but then it's going to override or provide the body for increase speed because it should provide it because it extended that class. So now we're providing that implementation here, right? And this method, the run method, is automatically inherited because it's extend vehicle. You don't need to redefine it. It can directly use that method. So once we have create an object, so say BMW, and I will specify just BMW is equal to new BMW. So this is an object, right? So BMW now can directly access to run method because it is inheriting from vehicle. So what is an interface? Interface in Java is a blueprint of a class, or we can say it is a collection of abstract methods and static constants. In an interface, each method is public and abstract, but it does not contain any constructor. Along with abstraction, interface also helps to achieve multiple inheritance in Java. Interface is a contract. So let's say you define one interface and all the clients know that this is an interface. And if any other company, let's say you have open source code and you define an interface, and that interface, if any company wants or any organization wants to provide the implementation for that interface, so they become a supplier for that interface, then what they need to do, they need to provide all the abstract methods body, right? Because in interface we don't have concrete methods, we only have abstract kind of methods, like where we don't specify any body, no implementation. So the class which is going to implement that interface, it is their responsibility to provide the method implementations as per their requirements. So the interface looks like this. So this is a public, then interface is a keyword, and then a parent car. So this is just a name, you can have any name, and then inside that you have a methods. So by default the methods are abstract. We don't need to specify that these are abstract method with abstract keyword because this is known that if there's an interface then the methods will be abstract, so there will be no body for it. And then I create a class Audi which implements a parent car which implements an interface, and then it must provide the implementation for the methods defined into a parent car interface. So it is providing that implementation here. Okay, we have discussed inheritance abstractions as well. Now we need to see what is polymorphism. So there are two types of polymorphism in Java, the compile time polymorphism and runtime polymorphism. We can perform polymorphism in Java by method overloading and method overriding. So in our previous talk, we have discussed several times that we're going to overload it and override it, but we haven't mentioned what are method overloading and method overriding. So let's discuss here what are method overloading and method overriding. So method overriding, right? So let's say you have a class named bike which has a method called run, and now you're going to create your own class, say Honda, which extends a bike class, but then you don't want to stick with that run method, right? Because your Honda ru- run in a specific way or in a different way from the bike class, right? So now you say, okay, I need some functionality from the bike, but the run method, I don't like it. I want to provide my own implementation for that run method. So what you say, I'm going to override the method which is defined into a parent class. So this thing what we're doing here, this we're doing overriding, right? I'm overriding this method, the method defined here, run method. I'm going to overriding it and going to provide my own implementation, right? And then when I go to my in a main class, when I need to create uh, the object of this class, and I say b dot run, at this point this method will be invoked, right, and not this method, because this has been overridden. And if its object is for Honda class, which is here, then it will call the method which is defined inside that class. I hope this is clear for you. What is method overloading? So some method name, but same method name, but different numbers of parameters or different data types of parameters. So what it means, method overloading. So you have one class calculator, right? This has a method print, void print, and it's take a parameter string and it's going to print it. So this is one method, right? So you want to provide a way in which you not only specify the string which need to be printed, but you also need to specify, for example, a page number and then a text which need to be printed. So now what you need to do, you need to modify this method, right? And you say, okay, my method take two parameters, but let's say there are few clients who are already using your print method, right? So their code will break, they won't be able to use that print method, and they need to change their code as well, right? And they will start complaining that my print method is not using which I'm using from your library. And then you need to specify, because we changed the method, now you need to specify a page number. Let's assume they don't have a page number to specify, right? So they will complain, okay, we don't have a page number to specify, what should we do? And then you will say, okay, if you don't have a page number, just provide zero there, right? Null value kind of thing, right? And it will work. But that's not a good solution, right? So the solution provided by object-oriented programming is method overloading. Method overloading means you create a same method name, so the print method name, but then you can change the number of parameters or a type of parameters. So a number of parameters or a type of parameters. So if you have a different number of parameters, so here we have only one parameter and here we have two parameters, right? So what we're doing, we overloading the method. So overloading means the same method will have different parameters or different number of parameters or different data types of parameters, and then inside that you can do a different implementation. Again, now you need to print not just a string but a first name and a surname, right? So what you're going to do, you don't have first name and surname as a one string, you have two strings, and you don't want to do concatenation before using the print, you want to pass them as it is. So the client asks you that he need one more method, so you say, okay, no problem, you can use the print method, but now this time when you call a print method, you can specify two strings, so first name and last name, right? So again, you are overloading your method name, which is a print method, you're going to overload it, and then again inside you provide a different implementation. So in nutshell, the overloading is a mechanism where you can use the same method name, but you can change the number of parameters or the types of the parameters. I give you example of a polymorphism with interface, how we can achieve a pure polymorphism with or by using an interface. So let's say you have an interface called printer and which print strings, right? So here there is no implementation because this is an interface, and you need to provide the implementation for that if you have a class for it. So my class HP implements printer, right? When it implements, it's going to override it. So this is the annotation we used to specify the compiler that I am going to override this method. So I say override and I'm going to provide my implementation as a HP company, right? And then there is a Canon company which also provide a printers, and they implements that printer interface which is defined here. And then it said, okay, I need to override that method as well. So it provides its own implementation here, right? Now when we need to use that, how are we going to use uh, that instance or that method, right? So first of all, what we need to do, we need to specify in our main method. Let's go to the next page and I will explain. Oh, okay, so before going to demo, I'm just going to explain that concept of the polymorphism. So let's say you have a class called HP, and this is HP is equal to new HP, right? If you create an instance like this, you cannot achieve a polymorphism because this is a bound to HP class, right? And then you can use a method. Let's say you have a method called the print, which take a printer, which is say HP, right? And then if the Canon came in, Canon want to provide something, then you need to create a new method, and then you will say, okay, Canon. It take a Canon object, so you say Canon object, right? So let's say you have like 20 companies coming and they want to use your print method. Every time they need to provide, you need to provide methods for each company, and that's not a good solution, right? That's not a polymorphism. So what the polymorphism is, that instead of creating an object like this, what you do, you say my printer, and then you say HP printer, right? So now because the HP implements the printer, you can specify HP like this, and then again the printer Canon is equal to new Canon, right? So now you have two instances, Canon and HP. If you want to print it, what you need to change in your print method now, you say print, and then you specify a printer P. So if I'm going to call this method, what I need to do, I just say print at an HP, I will pass it HP. If I need to call for a Canon, I will just say Canon. And how this is possible? This is possible because of polymorphism, because this printer is an interface, right? And when we specify interface, it is a contract. The contract says the printer will be passed. So in this case, the printer is Canon, right? And in this case, printer is HP. So this is a magically a polymorphism done. Then you don't need to rewrite a methods for all kind of objects. Instead, you can use the type interface as a parameter, and then you can pass any kind of objects inside which implements that interface. So hopes that's clear. Let's jump to the demo, and I will make more clarity there. We do more examples there, and you will understand all the concepts for what inheritance is, abstraction is, polymorphism is, method overloading and method overriding, right? And where we can use interfaces and what are the benefits. So let's jump to the demo part. I've created one class name is vehicle, and it has the properties speed, the name of the class, and the number of gears. The constructor is taking speed, name, and gears and assigning those values to these properties. Then it has a method, run method. Let's say car is running at speed and specifying the value of speed, at gear, and the number of gear it is running at. Then there is another method called music. I say it play music, so just print out play music. And then we have a getters and setters for all these properties defined because they are private properties defined here. Then we have a class BMW, which extends vehicle class, so that's inheritance. And then it has its own constructor, and it is calling a super. That super means the constructor of a super class or a parent class, which is this class. So this, when we say super and pass this value, it is going to actually call this constructor. And then we have a method called music. So if you notice that we already have one method here, music, right? And then we overriding that method here. So we are overriding this method because we don't want to run this method. We want to specify the implementation for our own method. So let's say play music in BMW, and then so this is overriding. So what we're doing it is here is, so this is overriding, but then the client said he want another type of music. Instead of just playing the plain music, you want to specify the type as well, like is it playing MP3 or MP4 or some other kind of format. So what we need to do, use the same method because we know the client is using it, but then just it will specify the type in the parameters, and now we can print that type as well. So this concept, what we're doing here, is called overloading, right? Because we already have a method in our class, but then we are going to specify a method again. If I remove this, so see, we're getting an error, and it's a error is saying duplicate method name, right? Because the music is already there. But if I will put any string in it or any type in it, then the error is gone, right? So going to save that one. Now coming to the main. So inside the main method, I have instance of BMW, and then I'm saying bmw.run. So if you see in the BMW, we don't have a run method, right? It means it is going to run the method which is inheriting from vehicle class. So this method is going to be run, right? And then we'll say bmw.music, and then it is not going to call this method because in the vehicle class this method has been overridden. So actually it is going to call this method which is defined inside BMW, right? So let's run this math and see the output. So if you see, the car is running at speed 240 at gear 4, and this is actually the values are coming from, we're specifying the values here in super constructor, and then constructor is setting those values which are here, right? And then when we call the method, we get those values here. So even though we don't have these properties defined in BMW, but still we are getting those values, and we don't have this run method defined in BMW, but still we are able to access that method because of inheritance. And the method is a play music in BMW. So this method is called, right? So the method is overridden and the overridden method is called. If we want to call overload method, we just say BMW music, and then we say what kind of music. So it's say MP3, save it, run it, and now you say the another method is called play music in BMW with MP3. So I hope you understand the concept of inheritance, the concept of method overloading and method overriding. If you see one thing here, we have private properties and we defined getters and setters here. So this is kind of encapsulating the properties and the methods within a class, and then we provide an abstraction that says no one will modify our properties directly, and then they need to use that method to modify the values. So I've created one interface. So the keyword is interface, and the name of the interface is printer, and it has one abstract method. We don't need to specify abstract in it because this is by default is an abstract method, and we named it a print. Then I've created one class. The class is HP class, which implements a printer. So if it implements a printer, then there is a contract that if you implement any method, you must provide the implementation for that method. So we say we're going to override that method and then going to specify the implementation. And in the implementation, I'm saying HP is printing. Then again, there's one class called Canon, which again implements a printer interface. So if it's implementing an interface, it must provide an implementation for the method defined in interface. So there is only one method called print, and in that method I'm providing an implementation called Canon is printing. So this is pretty much simpler. There's one interface called printer which has one abstract method called print. Then there is a class HP. It is going to implement printer and then override the method the providing implementation. Again, the Canon class which implement printer and provide an implementation. Now in our main, I'm going to create an instance of HP, right? And this is coming from printer because this is of the same type because it implements, right? And then Canon, again Canon is a type of a printer because it implements a printer. And then I have defined one static method here, and it takes a parameter as a printer, and then it is calling a method p.print, so which is actually calling a method which is inside the printer class. But what will happen, the polymorphism in the polymorphism mechanism, it will actually not going to call the method defined inside the printer interface, but it is actually looking the exact type of that object, which in first case when I provide this one, it will automatically find out that this printer is actually the HP printer. And then when I call this the Canon, it will find out that the printer is actually the Canon printer. So when I call this method, it should give me the output that HP is printing. And when I call this method, it will automatically configure that this is a Canon object, which is a type of printer. So that will say Canon is printing. So let's run this and see the output. So on this call, we getting HP is printing, and on this call, we getting Canon is printing. And this is a magic of polymorphism. So if I'm not going to define a polymorphism, for example, if I say take my HP, this P is capital, so HP is a new HP, right? And then I'm saying Canon, new Canon, and I'm going to run this. Again, the HP is printing and Canon is printing. And why? Because when it goes to the HP class, it knows that it implements the printer. So they have the same types, right? So we can do like this. But if I specify here HP, capital P, now you see an error here on the Canon, because for the Canon we don't have a print me method. So if I need for a Canon, I need to specify a new method here, and I will say this is for Canon, right? And then error is gone. I'll run this and you're getting the same output. But the problem with this kind of mechanism is, for let's say you have 20 companies which are going to use that printing facility, or they are going to implement the printer because they are in a market and they are providing a printers. So you need to write that print me method around 20 times. But that's not a good solution, right? So it's like overheads, maintainability will be not there, testing will be a big issue. So you need to test the method for all, you need to write it unit test cases, then the QA need to test for all the methods. So that's the big hassle, right? So in order to avoid that, we are using an interface. So I say here printer P, then we don't need to define a method for Canon, and I'm going to save it, and then we'll see the same output will be getting. So this is a concept of is interface, and we can achieve a polymorphism through an interface. So we can have a many forms. So one method can take many forms and provide the required solutions. So the polymorphism are of three kinds: method overloading, method overriding, and with the interfaces we can get a polymorphism where we have many different forms with one method. So we can specify it. Okay, if I pass an object which is of a types printer, then you can use a print method which is defined inside the class. So that's pretty much from this demo. I hope things are clear about object-oriented programming, what are in encapsulation, abstraction. We haven't discussed abstraction in the demo too much. Abstraction is very simple thing. All you need to do, for example, you have your class, vehicle class. So you need to say my vehicle class is an abstract class. So you say public abstract class, and then your class will be abstract. You can provide the concrete methods here, right? So these are the concrete methods, but let's say there is one more method which is abstract method. Abstract void, and say engine speed, right? So this is abstract method. I'm going to save it. And if you go to your BMW class now, which actually extends vehicle, you see the error is coming. And why? Because you have now unimplemented method, because this method is abstract, and if you're going to extend that class, you must provide the implementation for that. So you click here, add implemented method, and then you see the method is overriding here, and now you need to specify here. Even if you don't specify any body, that's fine, because it can be an empty body. There's no implementation there, there's no issue, but at least you need to specify that I'm going to override it, and then when I override it, there is nothing inside. So I hope you understand the concept of the abstraction, that how we create abstract class, and how the class extends that abstract class and provide the implementation for abstract methods. So see you in the next lecture. Till then, take care. Bye.